The process one, the energy stored in the capacitor EC and heat dissipated across the ET. Means it will close the switch. The capacitor, what happened after long time? What is the drop across capacitor will be V naught. Then what is work done by cell? Energy dissipated across resistor plus energy potentially stored in capacitor. We know half of the work done will go in capacitor. Remaining of will be dissipated as heat. And these two, heat dissipated and energy stored will be equal. There's a question button. At least I think students know, if you are very smart, at least you should have done this question but 10. Nothing to do. 11, what happened is you have to look at the graph and you have to come within a method here. Process 2 is complete like this. Process 2 is this much. From year to year, we are making changes. Process 2 is like this. Process 1 is directly that one. So he's just asking, will heat dissipated across the resistor, will it be same in both the cases? That's what he mean to say here. I'll charge the capacitor by stepwise. Then I'll directly charge by potential V naught. Here stepwise I'll increase. What will be the heat dissipated across resistor? Will it be same or different? That's what the question is he mean to say here. Okay, process the question number 10. Okay, all of you. Question number 10. What is the reason? Half of the work done by cell will be stored in resistor, will be stored in capacitor. Remaining off will be dissipated across the resistor. Therefore, EC should be equal to TD. Okay, 10. I think all of you understood. I'm proceeding further. Okay, let's come for the process 2. Stepwise. So first, what will happen? From 0 volt, it is made to V naught by 3. So if you want, what you do is like, you can write this as like a 1, 2, no? I'll shade it. Okay, here you calculate what is the energy that is heat dissipated across resistor. Again, you calculate for this region. Then again, you calculate for this region. I think this was the second part of the question. Get into the picture.
A option.
Yeah. Solved or already you know?
I solved.
And then okay. First, for the graph like this, I'll put like this. Region 1. I'll come for here. In the region 1, so what is the charge on capacitor will be? So Q1, I'll write it. So it should be CV naught by 3. Then what is the energy stored in the capacitor? U1 will write it. Q1 square by 2C. This will be CV naught square by 18C. I'm writing directly.
Instead, we can find out work done by cell now, sir.
Okay.
Work done by cell minus
what everyone
energy
should,
of capacitor.
everyone should think like you only. Any rule? Nothing, no? Let me just follow the basic method. The energy stored, work done by the cell, half of it will go in that one. So why I'm trying to avoid is like in the next part, I should have a clarity, no? So this energy. So what is work done by the cell in the first region? So Q1 into V naught. But what is the, I think, sorry, okay. How much? V naught by 3. What is given? C V naught by 3. C V naught square by 9. Okay, there's a work done by the cell. W1 for work done, U means energy stored here. What about the energy heat loss? W1 minus U1. So E close, I'll write H1. Okay, and W1 minus U1. Okay, this is about the region 1. Region 2, I'll take it. Now, when it comes for region 2, already the capacitor is having some charge, and finally it has become 2 V naught by 3. What is the charge? Charge will be, I should write potential difference. This will be, so this will be the 2C V naught by 3. This will be the final charge. Then extra charge, how much of charge will flow? Earlier was charge was how much? V naught by 3. Now 2 V naught by 3. What was the charge flown through the cell? Delta Q. Let me write it here. So there should be the Q2 minus Q1. Shall I need not to draw a circuit. This is the charge flown. Charge flown in, I think already I put a region 2, no, it is understood. This is a charge flow. So Q2 minus Q1. Q2 is 2 CV naught by 3 Q1. So this will be CV naught by 3. What is work done by the cell? W2 should be equal to delta Q into 2 V naught by 3. But the potential will vary from V naught by 2. It is very sudden. No? So it is brought. Now here is what the work done by the cell, not during, because say, look at this vertical part of the curve. This particular curve is vertical, no? From V naught by 3, the EMF of cell has become 2 V naught by 3. Now the capacitor gets charged. Able to understand? Don't think that the EMF of cell will vary gradually. Suddenly, from V naught by 3, the EMF of cell is 2 V naught by 3. Now the capacitor gets charged. What is the charge flown? Delta Q. What is delta Q for this interval of time? So definitely the cell now will push a charge. It does work. This is the thing. So we know. So what is work done by the cell? 2C V naught square by 9. Energy stored in the capacitor. Finally, what is the charge in capacitor? 2C V naught. So energy stored in the capacitor should be Q2 square by 2C. So 4C V naught square by 18. These are for region 2. What is the heat generated here? Heat generated should be work done by the cell minus energy stored in the capacitor. Will agree this equation? W2 minus U2, if you anybody value. Anybody value?
0.
0, sir.
0 you're getting, huh? Oh, already wait. Some correction I have to do.
Initial energy you did not consider.
Initial energy I didn't consider. U1 plus work done by cell should be equal to U2 plus heat. Yeah, now it will come. The same idea what we earlier proceeded. Substitute all this. I'll write it here, this one. Anybody value H2? Give me value H2. I'll go for region 3.
V naught square by 18.
3 V naught square by.
C, sir. C V naught square by 18.
Okay, this is H2. Okay, after this, now again come for region 3. Again, the same idea. Final charge will be C into V naught. Then final energy stored in capacitor will be then additional charge flown through the circuit, charge flown. This should be equal to how much? So what was the final charge? Final charge was CV naught. Initial charge was Q2. CV naught by 3 is the charge flown. Okay, look at the condition after this. So what is work done by the cell? Now we'll get the work done by the cell. Should be equal to delta Q dash, you write it. Delta Q dash into V naught. So this is the work done by cell. Final energy stored in capacitor. Again, what is the heat generated? It should be U2 plus work done by the cell plus U3 plus H3. Anybody value H3?
CV naught square by 18 only.
CV naught square by 18. No. Total heat generated is asking. The total energy dissipated across the resistance CD in the process 2. Process 2 means complete this one like this. So total heat generated. Answer for this.
CV naught square by 6.
CV naught square by 6. Huh? Okay, now is there any differences there? So the way we charge a capacitor, I think. Now first process, how much of heat will be generated? CV naught square by 2. Here how much it will be? CV naught square by 3, which will be greater. I think in the process 1. Process 1, what is the energy dissipated will be CV naught square by 2. In process 2, what happened? This is a heat. CV naught square by 2. Weight is less, it is less here, no? So how to save energy? These are the methods. I think in exam, any method you apply, it's not like teacher, because I just wanted to explain things clearly. I had to think in this way as a teacher. In exams, it's left to you like that. You are able to able to analyze, get the answer. Okay, you can do that. For the idea of this is what students usually miss. That's why I told you there's a universal thinking. Please do develop. Where all capacitor circuit comes now, even if external agent comes, that effect of external agent you have to include in RHS, LHS. Effect of external agent you should include in LHS. So it's a universal condition where all capacitor there no work done, something comes, no, you can take help of this one. Most of the students, what happened, everything is fine. See, there's a only this was the biggest trouble for them. How to write this? Even if you look at the books, no, they're not given that in order. They have done some method. They if you look at the solution of most of the books, no, they brought this H3 by some method. The students are not getting so how to do this. So just stick on to the conditions which are given in Redo. It's a universal, no, anybody can, if you know this method, I think it's very easy. No complication, nothing. And some students, what they took is like they didn't took region 1. Huh? They thought like only these are the things. No, it's starting from 0 to V naught by 3, V naught by 2, V naught by 3, 2 V naught by 3 to V naught. Like this stepwise is increasing, then it's asking you to analyze. In exams, such things really matters a lot. Huh? Why questions not there?